So I hope everybody's getting more comfortable with delta G as a concept and as a way to calculate spontaneous versus non-spontaneous processes. If you need to, watch some of those previous videos again. Make sure you can calculate delta G from H and S values. Make sure that you can calculate delta H and delta S to calculate delta G, and that you're able to calculate delta G based on given delta G of formation exam. There's 3 ways to solve those problems. You gotta work with the way that was given to you. So as we think about delta G and the position of equilibrium, we're heading toward how they're related to each other, and they are very closely related. When delta G is positive, delta G is greater than 0, equilibrium favors reactants. And so when we look at a situation like that, when equilibrium favors reactants, to us that looks non-spontaneous. It's not making much product. There's still a lot of reactant left over. This was also the scenario when K was small, right? When K was small, we didn't make much product. There's a lot of reactants left over. When delta G is less than 0, so delta G is negative, equilibrium favors products. These appear spontaneous. Because it's usually easy to see lots of product being made in those scenarios. That was also the case when K was large. If K was 10 to the second, 10 to the third, 10 to the eighth, we expected lots of product to be made. So there's a relationship between the size of K and the sign on delta G. Small k, G is less than 0. Big K, small k, G is greater than 0. Big K, G is less than 0. When delta G equals 0, that's the case where that system is at equilibrium and it doesn't appear to be moving left or right. It doesn't appear to be spontaneous at all. That was analogous to K having a numeric value of 1, where it didn't favor reactants or products, either one. Okay. So we're going to come back in a second and we're going to look at a scenario where we calculate delta G as standard conditions and at a different set of conditions. And then we start working toward, if that's what delta G is, what must the value of the equilibrium constant be? Okay?